Oh, and then a calculator. T-test is just a calculator test. Don't overthink it. I love you. Okay. So we did this in class Monday, if you were here. If not, that's okay. And this is about the t-test. So it's short, and that's fine because it's just like one more thing you can do in your calculator. The t-test is called also students t-test. So like in Google, sometimes you'll see that. And it's because this guy like needed it for something, and then he like invented it and published it under like anonymous, and so, or maybe he signed it student, I don't remember, but that's why it has no real name. Okay, so the t-test is used for two data sets that measure the same thing and only applies to normally distributed. So I'm going to zoom in. Normally distributed. The lines are squiggly from the copier, so sorry. So again, that's like your bell curve. Ooh, that's not very good. That's a bell curve. I'm sorry. Okay, and you'll use the calculator for this. Like, you're not gonna do this by hand, because, well, we don't have to, so let's not. So the first thing you'll do is set up your null and alternative hypotheses. The null hypothesis sort of is always the same. Is that the two means, so the average of the first thing and the average of the second thing, are equal. So in notation it looks like this. This is supposed to be two dots, not an equal sign, so sorry about that. The alternative hypothesis is that they are not equal. So again, you either have like one or the other. And so I need a pen. So for a two-tailed test, so again, you would like be on both sides of your normal distribution, like up here. You are going to check that the first mean is not equal to the second mean. For a one-tailed test, which is what we have in our example that we did in class, so one-tailed test, you just check that one of them is either less than, or it could also be greater than, but you would like know that, you know. Well, you would see it. I added this because it comes up in our example. It's okay to have a negative t statistic. So a negative t statistic is okay. It means that so like the value that you're going to find, it lies to the left of the mean. So if you like step away from this and come back and you're like, oh no, I have a negative number, like it's totally valid, it's okay. So again, let's say you have your mean is here, and it's going to be 0 for a reason, so just 1 second. Choop. And would you? So this is a t distribution. And it means that a negative t statistic means that you're somewhere like over here, right? Like you're like below the mean. And you'll see in our example, we have a mean of like, it's like 44 or something. 40, I don't know what it is. So you're below the mean. That's okay. Okay. So I did a little calculator here thing for you. One thing is that like you're always going to be in your like second, and you have your list. So we're going to use list for this statistic. And so you want to put your data into two lists. It's under test, so again you like go to your stat, and it's the two sample t-test, and then you kind of like have these things. You have to choose the correct alternative hypothesis. Because the null hypothesis is that they're equal, generally it's like set for you, but you might have to change it, just like sort of depends. We're gonna leave it pooled. That should be the default. But yeah, so that's sort of, again, it's like one more test. So you literally do this on the calculator. And then third, once you have found the p-value, you can compare it with the significance. Oh, I forgot to do this in class. This got cut off. Significance level, just like we did with chi-square. So if, for example, p is greater than the significance level, the null hypothesis is accepted. I'm going to zoom out for a second. If p is less than the significance level, then it's rejected. So that's what goes here. Let's write that. Rejected. Usually the t-test is conducted at the 5% level, but it can also happen at 1 and 10. So remember that this is 0.05, 0.01, 0.1. Just so this would be like accepted, this would be rejected. Okay. I feel like I don't know if we said more in class. So that's the general like outline. So you're going to have two things that you're comparing. You're going to, let me fix this actually. This is bothering me. Okay. And then you're going to use your calculator to like run that test for you. Same thing. Okay. Bye. Okay. So example 8 is from the book. And this is from, I'm going to zoom in, page 408. And then I think it goes to 409. Okay, so you have a situation. You have a little data set here. You're going to write down null and alternative hypothesis. And hypotheses, plural, excuse me. You're going to find the t-value, find the p-value, say like if you accept or reject. So again, this is just one different thing. The data for this, right, has to be normally distributed. So if you didn't have data that was normally distributed, you wouldn't run this test, you'd run something else. Okay, so the situation is that an oil company claims, right, so here's their claim. So like thinking about our hypothesis, they claim to have developed a fuel that will increase the distance traveled for every liter of fuel. 10 scooters are filled with 1 liter of normal fuel. Okay, 10 scooters are filled with 1 liter of the new fuel. The distances in kilometers traveled on the 1 liter by each scooter are as follows. So when I entered this, this was list 1. This was list 2. So again, you enter this into your calculator. You can enter them at the same time and run like 2 variable stats. So when I ran that, and it will give you x bar means the mean. So this is what I got. So x bar is like the mean of x. Yeah? Okay. And again, I previously did this, so you would do this on your calculator. 48.8. So here, from your calculations, right, you might see that they are not equivalent, but we're going to formalize this and make it legit. Okay, my cat's making noise, so that's fine. All right, so the null hypothesis is that they're equal. So these two things. So, right, like these two things are equal. So in words, there is no difference, right? They're equal between the distance traveled. I'm going to do 1L because I am of the type, the United States spelling. Okay, traveled with original and new fuels. And I was struggling to write fuels, so I'm going to try my best. Okay, so that's the null hypothesis. That's like the default. So like there's like no guesswork in theory. Oh my gosh, this cat. So the second one, because, does it tell you? Oh, I'm going to add a note. So the alternative is that they're not equal, right? So this would be like this. So inwards, the distance traveled with the original fuel is less than the joys of having a kitten in the house, is less than the new fuel. So again, I'm comparing two things. Okay, 1 second. Okay, I'm back. All right, so you've got your two hypotheses. So either they're equal or they're not. And because of the claim, right? So we're comparing the distance traveled with original and new. We're only looking at distance. This is a one-tail test. So this is, I'm going to write this over here. If you weren't sure, you could run both. And sometimes they tell you to, like, you know, this is one tail, whatever. So this is a one-tail test because BC, we're only considering the distance traveled with the original and the new fuel. Okay, so when you enter this in and you go to your calculator, oh my gosh, my cats are so annoying sometimes. They're cute though. Hopefully you can't hear them too much on the microphone. So you get negative 2.83. And then I think in the book it said a different p-value, but you know what? I checked and I double checked, and they're not, either way it works. So just heads up on that. So you get negative 2.83 and you get 0.001. So, and we're running this test at the 5% significance level. So remember that that's 0.05. Okay, so we're going to use P to accept or reject. So since 0.011 is less than 0.05, so that's our p-value, H naught, or the null hypothesis, is rejected. So that means that there is a difference. There is a difference between the original and the new fuel. So what this really means is that, like, the claim is true, or is substantiated. The claim is true, period. Okay, so that's how that works. In our capacity, I don't think we're gonna look at the t distribution. Like, I actually have to double check, but I don't believe so. I think it's just like you literally run it on the calculator and you either accept or reject. The one thing that, like before this week, I was gonna have you do for this, so you should choose one problem from this section from 8G to try out. Right? Practice. Okay. Hope that helps.